Okay? Yep. Good to go? All right. Welcome. My topic for the virtual brown bag for VMware 2013 is software-defined data centers like a Harmony remote. And so we're going to walk through a bunch of things related to the concepts that are in parallel to a Harmony remote control and a software-defined data center, and trying to point out maybe where we have some missing abstraction layers that are going to be critical to the next step. So with that, my name is Keith Norbie, and I'm with TIG. We're a solution provider, and so I've been in the virtualization community for quite a while. A real early follower and adopter of SDDC, and just trying to understand the concepts as all of us have gone through the virtualization realm. And ultimately, the whole background and the whole, I guess, setup for software-defined data center is a lot of folks will look at that and say, well, it's all marketing, it's all fluff. But in realistic terms, you know, a lot of this starts at the visionary level and then works its way through in terms of execution. So I think we have to be careful not to overly be negative and overly be too positive, and just simply try to work through what we can do to help the concepts that helped us in the early days of virtualization to where we are today. So with that, let's start first with the concept related to this, the Harmony remote. So everyone's got the home audio gear, everyone's got the multiple components, the TV, the VCR, the DVD, the Blu-ray player, the AV receiver, and they're all different manufacturers of these products. And so the Logitech remote came out before Logitech bought them, and they had a concept which was pretty basic, that a universal remote, and they were trying to address this mess, you know, of having, you know, potentially 3, 4, or 5 different remotes that would be individually controlling separate things. And so the industry came out with a universal remote that would have, you press a button to control your TV, and you press a button to control your device, and you press a button to control your thing. So it really was just a knob that would really move you back and forth and back and forth. And it really didn't provide that much automation to help you really run the home AV. So what did they do? They came out with a concept that was really revolutionary at the time, an internet programmable remote. And again, we're sitting here talking about data center technologies, end-user computing technologies, cloud technologies, and so what are we doing talking about a home AV remote? Well, the home AV remote, you know, simply put, this thing revolutionized the way you would watch TV or watch a movie at home. And ultimately, like with end-user computing, it's the non-technical people who are the best judges of this. So it's folks like my wife, my friends, neighbors that would come over, and, you know, a babysitter, you wouldn't have to explain how to watch a TV, because she'd hit the button that says watch TV. So what did they do? They built up a whole abstraction automation layer built within the interface of this internet programmable remote. And in that internet programmable remote, they recognized, you know, the over 5,000 of these disparate devices. And just like you'd have with the old remote controls, the universal remotes where you'd have to punch in program codes, they basically took that and simplified that one step further and really made a catalog of devices that you could go into and inventory on the website and really start to build activities around that. So when you look at those 5,000 disparate components, you know, we're talking about the TVs, the Blu-ray players, the receivers, etc. And then you look at, well, what do I want them to come out to as an end output? You'd want to watch TV, you'd want to watch a movie, you'd want to do X, Y, or Z. And so you could have these activities on the buttons and the remote, as well as some programmable activities that you could customize and even name. And so the whole thing was designed for supreme ease of use and automation at scale. So this abstraction layer would take these disparate devices and ultimately make them subservient to, you know, basically the run booking of each of the activity buttons and what they would do. So if I click watch TV, my volume up, volume down was controlling the receiver. My channel up, channel down was going to my satellite receiver. And my power on, power off would set a sequence of things to turn on the receiver, turn on the TV, put it to HDMI 1, have the audio kick in, and ultimately everything's working. And no one would have to actually do that in that sequence. The automation was all built in the abstraction logic layer. And so it's incredibly important to know that and sort of see that parallel analogy to get the whole strategy on why this plays forward in the future. So, we've known about virtualization and virtual machines for a long time, and this was really a nice revolutionary thing, 4 or 5 years ago when we were talking about taking resources like a CPU, memory, I/O, etc., and all these disparate different servers and storage, and virtualizing them into something that was highly elastic for us to be able to do things like vMotion. So, as we've now had that run for years and years, and we're on vSphere 5.1 and now 5.5 as it was announced at VMworld 2013 here in the keynotes, we now have a very modern hypervisor way to do compute. Well, so what if in the software-defined data center, the whole thing starts with, what if we abstract, pull, and automate not just the virtual machine and really take it to the next level and make it something that applied to the entire data center. So all of a sudden, everything that you used to do and be able to pool, abstract, and automate on a virtual machine level could be done in a whole data center level. And that becomes the new manageable unit. And ultimately, that becomes subservient to applications. So software-defined data center, a lot of folks have seen this messaging in the past. It's the concept where you can start to go beyond just the abstracting and the pooling, and you start getting into some very high-end, automation layers. So why do we need this? What's the deal around software-defined data center? And this is not any news to anybody. We have these silos of even virtualized environments. The Windows servers might be, virtualized into one pool group. The databases, tier 1 apps might be abstracted into another pool group. Mission critical, you might have high performance computing on a different pool group, et cetera, et cetera. Now, as you move that forward, and you've got what's been described from VMware and others in a software-defined data center as a whole management layer of compute, storage availability, network security, and you have all of the OSs and all the applications that would basically utilize a software-defined data center. But what's missing? In this case, my argument is, much like the Harmony Remote has that abstraction layer, we're missing that abstraction layer of logic to be able to have each of these components work with the actual applications and the operating systems for the applications. So, if you look at, the VMworld keynote, Pat Gelsinger talked about, the end attributes of the 4 quadrants. And here we've got the compute element, we've got the storage element, we've got the network element, and we've got the management element. And again, these are great because they start to define different dimensions of things you have to kind of capture and you have to account for. But, again, how do you make all that work to, say, an Exchange environment, a SQL database, even applications? And if you look at VMware vCloud and the construction of vApps, you start to get a nature for how this might look in the future, where you have multiple virtual machines constructing to represent one application and its usage in a business environment. So here we are at the final conclusion of the differentiation, and we've got a software-defined data center and a Harmony Remote. And again, we've got all the same consistent layers between the software-defined components, and everyone's been talking about how they have software-defined storage and they have software-defined networks, and everyone's talking about what they have software-defined. And just like that, the Harmony Remote's got their, software-defined components as well, because they built the abstraction layer of logic that helps to tie all those components together. Now, it's easy for Logitech and for one manufacturer to do that because these are commodity components, they're not quite data center components. There's much less complexity in how they pulled off what they did. But the net of it is, they still own a proprietary API logic that they can control based on the disparate manufacturer things. The question will be when we get into the software-defined data center year over year as this progresses forward, what new abstraction layer is going to come out? And how is that going to work? Is that all going to be sort of shepherded by VMware? Is it going to be OpenStack, moving that forward? Who's going to really be driving the middle layer of logic between the applications and the automations to be able to create SLAs for applications and some of the things that help define a data center as the new attribute for a virtual machine or a control element? How is that going to come out and get us beyond just infrastructure as a service? And the abstraction layer is really where all the questions are going to have to be resolved for us to get to where we need to get to. And a great example, just in a really good microcosm, is something like the tin tree, where they take very complex, storage and requirements and make them subservient to a virtual machine without you being able to find any kind of a natural storage element or attribute. Normally you'd have to manage a LUN or a file system. Tintry just manages it right up to a VM and attaches it to that VM. And so you just have to make your policies and your requirements in the VM itself, and it takes and it runs the whole parameters across the Tintry architecture. And that's just one example. So whether a vendor is going to lead that charge for the abstraction layer, or a manufacturer like VMware that really owns and runs a lot of the hypervisor layer and management layers is going to create the abstraction layer, or if it's a consortium group or a community source group like OpenStack, it'll be interesting to see how that plays out over time. With that, that's the conclusion of my presentation, and I want to say thanks to the Brownbags folks and for you guys to attend. Any questions? No, thank you.